Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. Don't forget to put your first and last name, period, and the date in the upper right-hand corner of your paper. And today's topic is the natural log. This is Unit 7, Lesson 9. And guess what, people? This is the last lesson of the semester. You're never going to have to watch another Edpuzzle of me talking again, at least for the rest of the school year. And you're all caught up and all that good stuff. So yeah, that's kind of exciting, right? I can't believe this is the last video I have to make this year. We did it, people. We did it. So our objective today is I will apply the log properties to natural logs and solve equations using natural logs. Mastery will be demonstrated by scoring at least an 80% in the next practice. So what in the world is a natural log? Well, it's another type of logarithm, but it's the log we use for the natural number e. So it's used with the natural number e. So whenever you see the natural number e and you're using logs, you always want to use the natural log. The natural log is simply ln. And I always write it as a cursive L because if you write ln like that, it looks like 1 times n. You don't want to get confused. So it's common practice to write the L as a cursive L. Anytime you see the natural log, it is always base e. But we don't write base e. It's understood that we're always using base e, but we write it as ln. So we always use base e, and it's written as ln. So you're always just going to see ln, and whenever you see that, you think the natural log. So the natural log base e. All right. So anytime you have the natural log of e, that means that you would have the natural log base e of e. And what do we know about logs where the base matches what's in the log? Those logs are always equal to 1. Because that means that e to the first is e, which is true. So the nice thing about the natural log is that the properties of logs are all the same. You just use ln instead of log. So for example, when we talk about the product property, you've got like the natural log of x times y can be rewritten as the natural log of x plus the natural log of y. Same for the quotient property. It's still the same idea, just with the natural log. So the natural log of x divided by y is the same thing as the natural log of x minus the natural log of y. And then last but not least, our super important power property that helps us solve equations and all kinds of things like that. We've got the natural log of x to the y can be rewritten as, and we're just doing that same thing where we bring the power out in front of the log and it changes to multiplication. So y times the natural log of x. All right, so now we're going to do some of the same exercises we did with the regular logs, where we have one log, the natural log of x squared times y cubed, and we want to rewrite this expression using as many logs as possible, as many natural logs as possible. So I've got the natural log of x squared times y cubed. That looks like the product property to me. So I can rewrite it. I'm going to put x squared and y cubed in their own natural log, and I'm going to add them. Then I'm going to use my power property, and I'm going to bring those exponents out in front of the logs, and I'm going to have 2 times the natural log of x plus 3 times the natural log of y as my final answer. All right, why don't you go ahead and give part B a shot on your own, press pause, and then press play when you're ready to check your work. So when you see division inside the log, you're going to think to yourself, we're going to use the quotient property. So I'm going to put x cubed in its own log. I'm going to put y squared z in its own log. Then I see I have the power property here. I'm going to bring that 3 out in front. So 3 times the natural log of x minus, and then this is y squared times z. So I can use the power property here. So, but I'm subtracting this whole thing because it was all in my denominator. The natural log of y squared plus the natural log of z. Then I'm going to distribute that negative sign. So I have 3 times the natural log of x minus, I'm going to go ahead and bring that exponent out in front of this log. So 2 times the natural log of y minus the natural log of z. And that would be my final answer. All right. Now we want to take this, and my directions are incorrect. We want to use the log properties to actually condense all of these logs into only one log. So 1/2 times the natural log of x plus 2 times the natural log of 3x minus 5. The first thing I'm going to do is I'm going to bring this 1/2 back into the log as an exponent. I'm going to bring this 2 back into the log as an exponent. Then I'm adding 2 logs. That reminds me of the product property. So I'm going to put them into one log together, and I'm going to multiply them times 3x minus 5 squared. And I'm actually going to put brackets around that thing so we know that we're taking the natural log of that entire expression. And then we're just going to leave our answer like that. All right, go ahead and give part B a shot on your own. Press pause and then press play when you're ready to check your work. So to simplify this thing, the first thing you probably did was the power property and brought these things in as exponents. So the natural log of x squared minus the natural log of x to the 1/3 power plus the natural log of y cubed. Then something that kind of helps me deal with this when I have subtraction and then addition, I'm going to rewrite this so that my addition is first and the subtraction is last. Then I'm going to use addition to multiply the first 2 logs into one log. And then because we have subtraction, we're going to rewrite this using division in one log. So the natural log of x squared y cubed divided by x to the 1/3. Now we need to keep simplifying it because we have powers with the same base right here, x squared divided by x to the 1/3. When I subtract powers with the same base, or when I divide powers with the same base, I subtract the exponents. So I'm going to have x to the 2 minus 1/3. So I'm going to take 2 minus 1/3. 2 is 6/3. So 6 minus 1 is 5. That simplifies to 5/3. So we're going to have the natural log of x to the 5/3 times y cubed as our final answer. And then we're done with that problem. Now we're going to just simplify some expressions. So 2 divided by e to the negative x. I never want to leave a negative exponent in my final answer. So to make it positive, I just move it up to the numerator, which leaves 1 in the denominator, which 2 times e to the x divided by 1 is just 2 times e to the x. For e to the x to the 4th, I'm taking a power to a power, so I multiply my exponents, so I get e to the 4x. Then I have e to the 1 minus x times e to the 3x. When I multiply powers with the same base, I add the exponents. So I'm going to have e to the 1 minus x plus 3x. Negative x plus 3x is 2x, and then plus 1. So e to the 2x plus 1 is my final answer. E to the 2x times 1 minus 5e to the 3x. I'm going to distribute. e to the 2x times 1 is e to the 2x. E to the 2x times negative 5 e to the 3x. I'm going to multiply, so I'm going to get 5 e to the 3x plus 2x. So I get e to the 2x minus 5 e to the 5x. And because these bases, e to the 2x and e to the 5x, aren't exactly the same, I can't subtract this any further. This is my final answer. All right. So those are just some expressions using the natural number e. Now we're going to simplify when we have e inside the natural log. So when you have e to the natural log of 5, e to the natural log, remember this is e to the natural log base e of 5. Whenever you have e to the natural log of something, e to the natural log of whatever just becomes 1, and then you're left with what was in the log in the power. So you're just left with 5. That's just kind of a rule you need to remember. Then the natural log of e squared. So use your power property, bring that 2 out in front. 2 times the natural log of e. Remember, this is base e. So whenever the base matches what's in the log, the natural log of e is just 1. 2 times 1 is 2. All right, so then what would 2 times the natural log of e simplify to? 2. The natural log of e is just 1. 1 times 2 is 2. All right, e to the 5 natural log of 2. So we can't just simplify this like we did the very first one. We need to use the power property first to bring this 5 back inside the log that's in the exponent. So e to the natural log of 2 to the 5th. Now e to the natural log cancels. We're left with 2 to the 5th. 2 to the 5th is 32. So our final answer is 32. All right, now let's solve some equations using natural logs. So the natural log of x equals 6. I'm going to need my handy dandy calculator for this. So the natural log of x equals 6. I feel like I forgot to mention this. I think I did. So if you have the natural log of, let's say, x equals y, that can be rewritten as e to the y equals x. Just like we did with our other types of logs. You can rewrite it in exponential form. So this guy is base e. This is e to the 6th equals x. So then x would be approximately, to get the e button, remember you hit second natural log on your calculator, and then you take e to the whatever power, we're taking it to the 6th power, which is 403.428 and 8. We're going to round it to the 4th decimal place. All right, why don't you go ahead and try part B on your own? Press pause and then press play when you're ready to check your work. So you should have rewritten this as e to the 1st is equal to 2x minus 1. E to the 1st is just e. You add 1 to both sides. Then divide both sides by 2. So we get x is equal to e plus 1 over 2. So x is approximately, you're going to take second natural log. So e to the 1st, hit enter, then add 1, hit enter, and divide by 2, hit enter. And you'll get 1.5, just kidding, because I can read, 1.8591. And now for some fun problems. So remember when we dealt with compounded continuously for our interest? Let's see here. We have Kimmy invests $4,000 at 3% interest rate, compounded continuously. How long will it take for her investment to double? So remember when we deal with compounded continuously, we use PERT A equals P times E to the RT. And this time we know that her initial investment was $4,000. We know that the rate is 3%. And we know that she's going to end up with, it's going to double. So 4,000 times 2 would be $8,000. We know she's going to end up with $8,000. We're trying to figure out how long it's going to take for that to happen. So we're going to plug this information into our equation. 8,000 is equal to 4,000 times E to the 0.03 times T. So T is an exponent. So let's try to isolate it as much as we can. The first thing we're going to do is divide both sides by 4,000. 8,000 divided by 4,000 is just 2 equals E to the 0.03 T. So now we have our variable in an exponent still. We need to bring it out of the exponent. And to do that, we need to use logs. But because we have the natural number E, we want to use the natural log. So what we're going to do is we're going to take the natural log of both sides of that equation. So remember, we can bring this out in front. So the natural log of 2 is equal to 0.03 T times the natural log of E. And something really handy happens. What's the natural log of E? Isn't that just 1? So the natural log of 2 is equal to 0.03 T times 1, which is just 0.03 T. Divide both sides by 0.03 and you'll get T. So T is equal to, let me get my handy dandy calculator here. We're going to take the natural log of 2. We're going to divide it by 0.03. We get 23.1. So it's going to take 23.1 years for this investment to double. So it will take 23.1 years for Kim's investment to double. All right, so I want to have you go ahead and do the second problem on your own now. Part B. Chelsea's investing $7,500 in an account paying 5% compounded continuously. She now has $10,643.01. How long has the money been in the account? So you're using the same equation. You're solving for T, follow the same steps we did in our previous example, and go ahead, press pause, and then press play when you're ready to check your work. You got this. All right, y'all, I got that it'll take 7 years for the investment to grow to that amount. So hopefully our answers match. If not, you can always ask me for help. I just want to say thanks for listening to all these videos all school year and taking your notes. And I really appreciate your hard work in this class. Make sure you go do your extra practice and let me know when you're done, and I'll see you guys back in class. Have a great day.